Welcome back, ladies and gents. Hope you had an amazing Christmas break. Today we're going to be talking about inconsistent and dependent systems of linear equations. Now, that may sound really crazy, but it's actually just kind of adding on a step to what we've been learning. So you're still going to be solving a system of equations using substitution or elimination, or if you really like to do a table, you can do it that way still. But you're just kind of, instead of one solution, you can get either no solutions or infinitely many solutions. Okay? So just to get you back in the game here, the warm-up is solve the system of equations either using a table, substitution, or elimination. So if you don't remember how to do this, remember you either need to solve for a variable and plug it in, that's substitution, or eliminate a variable. If you've kind of forgotten, go ahead and go back, watch some videos, look at your homework, look at your notes. Okay, that should help you. Okay, so in this case, you're going to get one solution. Okay, you're going to get some x equals something and y equals something. Okay, and remember when you graph it, we've talked about this a little bit, when you graph the two lines, wherever they graph, they'll intersect at one point. Okay, and we're going to talk about that more in a later section. Okay. Now in this equation here, it says the definition, inconsistent, a system of equations that has no solution. These lines never touch each other. Okay, they never intersect anywhere. So they're parallel lines, okay? So this is another way to think about it, is parallel lines, okay? Oops, sorry. So I just kind of wrote the general note to self, parallel lines there. Okay, so I'm still going to solve it using substitution or elimination. I personally prefer elimination, but if you really like substitution, you can do that. I'm just going to write my equations a little bit bigger here so I can see what's going on. Okay, and I'm going to choose to cancel out the y variable, just to make my life easier. So I know this is a positive 2y and this is a positive 1y. Remember there's an invisible 1 there. So I'm going to multiply the top equation by negative 2. So I'm going to rewrite my equation off to the side here. So negative 2 times 2x is negative 4x. Negative 2 times 1y is plus a negative 2y equals, remember you have to multiply by that last variable. Oh, sorry, you guys can't see everything here. Negative 2 times 1 gives me negative 2. And then I'm just going to rewrite my other equation off to the side here. Okay. Now notice I have my two top to bottom equations here, nice and neat for you. And I'm going to add them together. Well, negative 4x plus 4x is 0. Okay, so that canceled. Negative 2y plus 2y, well that also cancels, and since everything cancels on this side, I'm going to write that it actually equals 0. Okay, so if everything cancels, write that it equals 0. Usually we don't write the 0 when we cancel something, but in this case we want to. And then negative 2 plus 4, that's 2. Does 0 ever equal 2? It doesn't, right? So that means this system is inconsistent. And what you guys will usually write instead of inconsistent, you'll just say no solution. And that's the answer to your problem. There's no solution. Okay? So what happens is this graph, the two lines, are parallel to each other. Okay? They never intersect each other, so there's no solution to the problem. Okay? And that's my little note here. No, inconsistent equations are parallel equations, or parallel lines, I should say. Parallel lines is a better way to say that. Okay? Alright, moving on. So next we're going to talk about a dependent system. A dependent system is a system of linear equations with infinitely many solutions. So basically what that means is they're exactly the same line, just kind of disguised. Okay, so if I look at these two equations, okay, again I'm just going to write them a little bigger to give myself some room to write here. Okay, again you're going to do the same thing. You want to eliminate a variable. Okay, so I'll start working on x. So this is a positive 2, this is positive 1, so I'm going to multiply the top one by negative 2. It happened to be the same number as the last one, but it's not always going to be negative 2. So negative 2 times 1 gives me negative 2x, negative 2 times 2 gives me negative 4y, negative 2 times negative 2 equals negative 4. Okay, so I just multiply negative 2 by everything. And then I'm going to rewrite this bottom equation. Okay, and then I'm going to zoom back in. So these are my two equations. Now notice again, something's going to happen. It's a little different than what we've been dealing with before. Negative 2x plus 2x cancels to be 0. Negative 4y plus 4y cancels. So since everything canceled on the left-hand side of the equals, I'm going to call that 0. Equals negative 4 plus 4, which is also 0. Does 0 always equal 0? Yes. So that means it's a dependent system. But usually what you guys are going to write for your answer is infinitely many solutions. Okay? This will be your answer. Infinitely many solutions, or just infinite. Okay? So today, your two answers are either going to be either some sort of x equals something, y equals something, dependent, or inconsistent. Okay? So dependent equations are the same equation when solved for y. So if you actually sat here and solved for y like we did way back, you would get the exact same equation in y equals mx plus b form. Okay? So here's your little cheat sheet. So this might be something good to write on a note card because final exams are coming up. Okay? So one solution means you get x equals something and y equals something. Okay? No solution means you get like 5 equals 3 or 0 equals 10 or two numbers that don't equal each other. Okay? And infinite solutions are when you get 0 equals 0 or 5 equals 5. So two numbers that always equal each other. Okay? So this is kind of your cheat sheet. Okay, so this might be something you might want written on a note card. So this would be a good time to pause it. Okay, so there's kind of 3 separate things here. Write this down and then work on your homework, okay? But before you move on your homework, you need to do the exit slip. And all it's saying is the system inconsistent, dependent, or does it have a unique solution? Unique solution just means one solution, okay? So you're going to solve this system just like we did. If you get x equals something and y equals something, it's a unique solution. If you get two numbers that don't equal, it's no solution. If you get two numbers that always equal, it's infinite solutions. Okay? Good luck and have a great day. Bye.